Okay, today we're doing lesson 2.2, that's module 2, lesson 2. And today's learning goal is for you to be able to find reasonable products. So you're not going to find the exact product, but you're going to find a product that's in the right zone or about the right size by first rounding the factors. So you can see we're going to use skills we learned from module 1, like how to round things, right? Round numbers, and also what it means to estimate. And also how to multiply things. So basically, we're taking everything we learned from Module 1 and Lesson 2.1, because didn't we learn how to multiply numbers by multiples of 10 yesterday? Yeah. Very good. Give me a thumbs up if you finished the workbook problems for practice at home. Oh, you're going to be in such good shape for today's lesson. Very good. Let's first talk about the problem of the day. Before we get started with today's math problem, I want you to write this down. What are the parts of a multiplication problem called? In the problem of the day, we just did 80 times 60 equals 4,800. There are 3 parts in this problem, right? Don't you see 3 numbers? There's one number here, and one number here. Yes? 3 numbers altogether. The numbers on the left of the equal sign, what do we call those? Factors. Good. So if I say do something round, if today it says find reasonable products by rounding the factors, what part are we rounding?
80 and 60.
The 80 and 60, we'd be rounding those, okay? What is the answer to a multiplication problem called? Jaden? It's not called a multiples. Emily? It's not called a sum. Ani? Product, good. So if a math problem says find the product, what is it telling you to do? It's telling you to multiply. If something says find the sum, like Emily said, what is it asking you to do? Add. If it says find the difference between 2 numbers,
Subtract.
Yeah, so first example, if it says find the difference between the actual amount and your estimated amount, what should you be doing? Subtracting. Very good. If it says find the quotient, what is that telling you to do? If it says find the product, what is it telling you to do? So if today's math learning goal says find reasonable products, we're finding the answer to a multiplication problem. Does that make sense? Okay, make sure you have this written down so you know what the different parts are called. Go ahead and write this problem in your notebook. 697 times 82. The directions say to round the factors. So both of these are factors, right? Because they're being multiplied by each other. Do we have any products here yet? No. We're going to round the factors in order to estimate the product. Do you see how there's wavy equal signs here? That means it's not exactly equal, but it means it's about. Okay? So when you draw wavy equal signs like this, that means it's about. So I wrote 697, which is the first factor, and 82, which is the second factor. Okay? So let's round those. 697 is pretty close to what number? 700. Okay? And 82 is pretty close to what number? 80. So therefore, 697 times 82 is pretty close to 700 times 80. Do you see that? Now, which problem is easier to do? 697 times 82 or 700 times 80?
700 times 80.
Yeah, because they're multiples of 10. Do you see that? And now we know that when we have multiples of 10, we can multiply the numbers. So we have 7 times 8, which is 56. And how many factors of 10 do we have? 1, 2, 3. So that means we need to add how many zeros? 1, 2, 3. So a reasonable estimate for 697 times 82 is?
56,000.
56,000. Very good. So when we round the factors, in order to find a reasonable estimate, we want to round it so that our factors are multiples of 10. Do you see that? Okay. When in life might we want to estimate instead of finding the exact answer? If I want to make sure I have enough money to pay for something, do I want the exact answer or an estimate? Maybe, right, if I'm just planning for something. But if I'm going to the store and I'm going to pay an exact amount, do I need to know the exact amount? But are there times in life where you just need to know an estimate?
Yeah.
Right? Okay, very good. So when you want to estimate the product, you round the factors so that the factors are multiples of 10. Does that make sense?
Yeah.
Good, let's try a couple more. Okay, our first expression is 8,840 times 45. That expression is given to us. It's a multiplication problem, right? So that means the two numbers that we're multiplying together are called what? Factors. Good. Let's round so that each factor, so that each factor is a multiple of 10. So 8,840 is pretty close to what number? 9,000. Very good. Is 9,000 a multiple of 10? Yes. Now, was 8,840 already a multiple of 10? But which one is easier to think about in your head, 9,000 or 8,840? 9,000. Yeah, so you're basically always looking at the second digit and seeing if it rounds the number up or if it stays the same. Do you see that? What about 45?
50.
Is 45 closer to 50 or to 40?
50.
Good. So the rounded factors could be 9,000 times 50. Do you agree?
Yeah.
Okay. So then let's estimate the product. We can look at the numbers first. 9 times 5, which is 45. And then how many factors of 10 do we have? 1, 2, 3, 4. So what does that mean we need to do to the product? Add 4 zeros. 1, 2, 3, 4. So a good estimate for 8,840 times 45 is
450,000.
450,000. Good. Try this bottom one on your own. Write the expression, write the rounded factors, and then write the estimate. In a single season, the New York Yankees, that's a baseball team in New York, they sell an average of 42,362 tickets for each of their 81 home games. That means that each home game, they sell 42,362 tickets. So if I want to find out exactly how many tickets were sold, what would I need to do? I would need to multiply 42,362 times how many games? 81. Can we do this math problem? Yes. We can. But if the problem says about how many tickets do they sell for an entire season of home games, do we need to find the exact answer? No. Okay, so we just take the important information that is 42,362 tickets, and there's 81 games altogether. So then our actual multiplication problem would be 42,362 times 81. But if it's just asking us to estimate, can we round the factors in order to estimate? Yeah. We sure can. 42,362 is pretty close to what number that's a lot easier to work with? Our Okay, we could do 42,000. 81 is pretty close to what number that's a lot easier to work with? Rohan? 80. Okay. Now, I don't know about you, but I can't do 42 times 80 in my head. Can you? Does that mean we can't do this?
No.
What do? We can write it out like this. 42 times 8, right? 8 times 2 is 16. 8 times 4 is 32. Plus 1 is
33.
So 42 times 8 is 336. So I can write 336, and I can look to see I have 1, 2, 3, 4 factors of 10. So I need to add 1, 2, 3, 4 zeros. So I could say they sell about 3,360,000 tickets. Okay. Now, some of you might be thinking, wait, Miss O, I know a different way to do it. Instead of saying that 42,362 is close to 42,000, I'm just going to say that it's close to 40,000. How many of you were thinking that?
Yeah.
I'm still going to round 81 to 80, and now I can do 4 times 3 in my head is 32, and then I can add 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. To get 3,200,000. This one was easier because I can do 4 times 8 in my head, whereas before I could not do 42 times 8 in my head, right? Which one's a better estimate? Which one's closer to the actual number? Talk to your table group. Okay, ladies and gentlemen, which one's going to be closer to the actual number? 3,360,000 or 3,200,000? Everyone?
3,260,000.
Right. This number, 3,360,000, is going to be closer to the actual number because 42,000 is closer to 42,362. So that's a closer estimate. It depends. I'm here to tell you there's no right answer. Right? It depends. If you want to be able to do it in your head, which one's a better way? 40,000 or 42,000?
40,000.
Right. But if you want to be closer to the actual number, which one's better?
42.
right? 42,000. Was it hard to do 42 times 8? No. So it's up to you in most cases if it's unclear. But I would say, for me, I feel like as long as it's not too hard to do, it took me maybe 1 second to do this math problem, right? It's better to be a little bit closer to the actual number. Does that make sense? But if you want to do it completely in your head, then this way is better. So I'm here to tell you there's no right answer. You got to figure out what works for you, and it depends.